Today's lesson is about the first model of machine learning, let me say the most simple one, the logistic regression. Logistic regression is a base of linear regression. As you can see in the picture, this is a curve that's having some this is a log curve, let's say, where the values are going approximately on the upper boundary till 1 and on the low boundary till 0. As you know, if we are having a graph, here the linear regression is going like this. And the linear regression is having some coefficient 1 multiplied by x values plus some coefficient 2 like 3 intercept. Let's say this is the intercept. In the logistic regression, this type of linear function is, let's say, modified and build the logistic regression. The logistic regression is mainly used for classification models. Not mainly, it's used only for classification models with values 1 or 0. So it's for binary classification only. Again, it's using this type of formula. Maybe you can have more than one input. This is the base linear regression. Also here you can have more than one input. That means more than one dimension. Let's take a look after we read the data and after we make the train test split. Now we need to build a model of logistic regression. Firstly, let's import the model. From sklearn, we are having a linear model package where we are importing the logistic regression. Now we are defining the model with the initializing the logistic regression with empty constructor. Then it's the part of training. Training of the model is with the help of dot fit. What's the training of the model? Let me show you. Now we are having the model. Here it is, the logistic regression. And on the input side comes some values. The training is what the model will learn, what values are going to be the coefficients standing before each of these three inputs. For predicting, in base of predicting, is this instance 0, 0 or 1. So we are making fit, we are learning the data, x train and epsilon train. The model learns with calculating the errors that comes with the prediction and the original data from epsilon train. Without the epsilon train data, you cannot train a model with supervised learning. Classification is part of the supervised learning where the the output is given. Now the part of testing is firstly with prediction. First, we need to make prediction of the model.predict, and at the prediction function, only the x-test data is given as argument because epsilon test it's not used. The predict only uses input data for predicting the classes that are anomaly detection. This is array with 0 and 1. Now, the evaluation part of the model. Here, we need to import some metrics for from sklearn. Let's import some metrics. Firstly, we can import confusion matrix, then F1 score, classification report. Let's take a look each of these what is doing. Print the confusion matrix of epsilon test, the original data, and the predicted one. Here we can see what is the confusion matrix. I think that we already passed this part. The confusion matrix is matrix when we are having 0 or 1, where here is the original data, here is the predicted data, 0 or 1. This is a true positive where the data originally is 0 and is predicted 0. This is false negative where the data is 0 but is predicted as 1. Here it's false positive where the data is 1 but it's predicted as 0, and true negative where the data is 1 and is predicted like 1. So we're having here bad prediction for ones, as we can see. Let's take a look of printing the classification report of epsilon test and epsilon prediction. Now, as you can see, F1 score is a great metric that uses some ratios of precision recall. So it's 0.9 for zeros, but for ones it's 0.04, which is very, very bad. At the end, let's take a look just of the F1 score for whole testing part of epsilon test and epsilon prediction. It's 0.04. It's very small. F1 score is in boundaries from 0 to 1. The model is good if the F1 score is close to 1. If it's close to 0, then the model is showing bad predictions. We can see here when we talked, we said that the data set may in some cases bring bad predictions based on their imbalance. So now we're gonna make balanced data set and try the same code one more time. So now let's build balance data. How we are building a balanced data, we're gonna import from learn oversampling. What is oversampling? Oversampling is when we are having more zeros in this case and less ones. Then this oversampling is putting ones the exact same times as zeros appear in the data. We are importing the random oversampler. This random oversampler is randomly choosing which instances of ones will be copied one more time, or how many times it needs to have value. So let's take a look. Oversampler, first let's import it from the instance of random sampler, and you can add a random state. It's how we'll get the raws. that we need here. If we have, for example, 5 zeros and one, uh, let's say 5 zeros here and one, it will take, okay, copy the one 4 more times. If we had two ones, then we'll randomly choose which one will take. For example, here the second, then the first, and at the end the second one more time will be copied. The oversampling is making maximum size of appearing instance and bus time class. Now let's make x resolved, epsilon resolved. Now with the oversampler, we're gonna fit resample make of x train and epsilon train. Now let's take from epsilon res value count. Now you can see that this is on upper value. 4,401 row ones and the same as zeros. If it was undersampling, then it will be just approximately 250. Now let's make again the model of logistic regression model.fit now on x press and epsilon. Let's build let's make epsilon predict. That's model.predict of x test. X test, it's not balanced because we want to see the originally data, how it's evaluated. We're just balancing the data that the model learns. Now let's make confusion matrix of epsilon test and new epsilon prediction. As you can see now, there are more ones going at this true negative ones are predicted as ones, but some zeros are here going into ones because the data is balanced, as you can see. Now print classification report of epsilon test and epsilon prediction. So this is with small letter. As you can see now, for the ones, the F1 score is 0.37, which is 3 times better. Maybe no, it's not three. It's more than 3 times better than the one in the unbalanced data set. At the end, let's take a look of the F1 score, epsilon test, and epsilon prediction. It's 0.36. As you can see, we made a progression of F1 score. It's not so good. The logistic regression, it's not showing great results, but we can obtain that with just balancing the data. We are going into some advantages when it comes to prediction. So the um, the importance of visualization and the pre-processing part is seen when it comes to bad model. And we can obtain that the regression is not the best model for our data. Also, we need to make balanced data if the model requires that.